Okay, so this morning class, we're going to use the rules of integration to integrate a function. The integration is actually the antiderivative. It's the opposite of the derivative. And when we're finding the antiderivative, we're going to look at, we need to understand our notation. This elongated S symbol is called the integral sign. This is called the integral sign. This is what's inside of that is called the integrand, and this is what we call a dummy variable. It is just telling us that we're taking the derivative with respect to x. So this lets us know that our final answer will have x's in it. Now, if you recall from last unit, when we found the derivative, we used the power rule. And what we did was, remember, we took the exponent and it dropped. Essentially, we were multiplying the exponent by the function, and then we subtracted 1 from the exponent. Because this is the antiderivative, we're going to do the opposite steps. So we're going to start by adding 1 to the exponent and then dividing it by the new exponent. And that gives us our power rule. Please take a second and write this down. So notice what we're doing the opposite of what we did the last time. We're adding 1 to n and then we're dividing. Now, what does this plus c mean? Well, if you recall, when we took the derivative of, let's say, 6x squared plus 3, the derivative of that became 12x. And that 3 sort of disappeared. It went to 0. So by saying c, we're saying we could have been adding a constant to the function. We don't know. And so to take into consideration that constant, we just add plus c. Also know that this will not work if n is equal to -1, because if n is equal to -1, we will end up dividing by 0. Okay, so take note of that we can't use this when n is equal to -1, and we always have to use c. If I could spell always use c. So every antiderivative of f of x must have, will be g of x plus c, where c is a constant. And we just talked about the need for c. So if we were to use the formula that you were given a minute ago, when I find the antiderivative of 6x, I begin by adding 1 to the exponent and then dividing by that exponent, which will give me 6x squared over 2, which is 3x squared. And then, what's the purpose of the c? We add the c because it could be any constant. So this represents every possible antiderivative of 6x. Let's try some examples. So we have x to the 4th dx. We're going to use the power rule. So we start by adding 1 to the exponent and then dividing 4 plus 1, and then dividing by 4 plus 1. For the next example, remember that we can write x to the square root of x as x to the 1/2. So we're going to add 1 to 1/2 and then divide by 1/2 plus 1. I'm going to clean that up by multiplying by the reciprocal, and so you can see that that would be 2/3 x to the 3/2 plus c. Okay, once again, for this next problem, we have to recall that we can write this as x to the 5th over 3. So then when we add 1 to the exponent and add 1 and then divide it and then divide by 5/3 plus 1, we get, and again, I'm going to clean that up. Okay, so remember at the very beginning I said that we cannot use this if x is equal to if n is equal to -1. But recall that 1 over x, the integral of that would be the natural log of x, because the natural log of x is the derivative of natural log of x is 1 over x, and it's just the antiderivative. The only purpose for these the absolute value symbols here is to remind us that x has to be positive because we can't take the natural log of a negative number. That's the purpose of that absolute value symbol. That will also help us remember that e to the x, the derivative of e to the x is e to the x, so the integral of e to the x is e to the x. We're going to deal more with b to the x, our constant raised to the x power. We're going to deal with that more in Unit 5, in the next unit. But this is just for your information right now. We have the sum and different rules, and the sum and different rules just says that the sum of two integrals is the integral of the sum. So if you're taking the integral of a polynomial, you just take the integral of each term, and that will be your solution. The constant multiple rule just says if you have a function and you're multiplying it by a constant, you can pull out the constant. There is no product rule in integrals. There is no quotient rule in integrals. Okay, so let's do some examples. We're essentially, in this first example, we're using the sum and difference rule. We're just going to take the integral of each term separately. So we have, this is one term, two terms. So we're going to take the integral of each of these terms. And I want you to note that this can be written as 5x to the 0. Because anything raised to the 0 power is 1, so I can write this as 5x to the 0. So when I take the integral of this using the power rule, I get x to the third over 3, and this will be adding 1 here. I get x squared, 3 divided by 2, and then minus 5x, because I have to add 1 to that 0, plus c. Now, before I can do this, there is no quotient rule of integrals. There is no quotient rule. So what I have to do first is to simplify this. And when I simplify this, I get x minus 4 over x. And now I take the integral of each of these separately. So the integral of x would be x squared over 2. And I'm going to have to use the natural log for this. So the integral of 4 over x would be 4 natural log x. Recalling that I can't do the integral of x to the negative 1, and I can write this as 4 times 1 over x. And the integral of 1 over x is the natural log of x. That's just one of those things that you have to know. And always remember your cookies, your C's. Once again, I have to simplify this before I can take the integral. So recall that this is x to the 1/2, and so I have to divide before I can take the integral, because there is no quotient rule in integration. There is no quotient rule. So this is going to be 1/2 minus 6/2, which would be 5/2. So this would be 1/4 x to the 5/2, negative 5/2, minus 1/4 x to the negative 2. Now, I treat these negative 5/2 and the negative 2 the same way with the power rule. The only one that I can't treat the same is x to the negative 1. But these I treat the same, so I'm going to add 1 to each of these. Adding 1. And cleaning that up, I get, okay? Anytime you need to pause this, you can. I'm giving you a moment to write this down. All right, let's do 3 more examples. What I would suggest is that you would try these, maybe pause the video and try them on your own. And I've tried to give you some hints. Remember, there is no product rule in integration. There is a chain rule that we will learn later, but for now, you're going to have to multiply everything out, simplify everything before you take the integral. Okay, so if you've had a chance to do these, the first thing we're going to do is multiply this out, or maybe not. I didn't show the multiplication out, but if we were to multiply this out, we get 4s squared plus 12s plus 9. And then we would integrate each of these individually. Multiplying this out, remember we add exponents, so this is x to the 1/3. And I can write 2 as 6 to the 3rd. That's the same as 2. So when I multiply that out, I get x to the 7/3 minus x to the 1/3. And then I'm going to integrate that using the power rule. Okay? I think that's 3/10. I kind of wrote over it, but it's 3/10 x to the 10/3. And then for the last one, I have to recall that the integral of e to the u is simply e to the u. And for this one, because this is like saying u to the -1, that's going to be the natural log. And then I would do this one regularly. This du just means that I'm taking the derivative with respect to u. It's just telling me what my variables are. Okay? So those are some examples. That's about as, well, I was about to say that's about as difficult as it's going to get, but let's do some trig. You need to be aware of these trig integrals, and I'm going to give you a moment to write this down. Once again, you can pause the video and just write these down. Okay, so let's do some examples with that. We're going to do this one just like we've done before. We're going to use power rule, and then we're going to use the rule that we know for sine. Notice that the integral of sine is going to be negative cosine because we're doing the opposite. So the integral of sine is going to be negative cosine. So using the power rule on t squared and knowing that the integral of sine is negative cosine, we get this. Don't forget your cookies. Don't forget your C's. Now, I know you don't like the way this looks, but this is still just x's. So I changed the variable. Notice I changed the variable here. It was dt because we had t's, and this is theta because we have thetas. But we're going to treat this just like it as if it were x squared minus secant squared x. Again, on the x squared, we're going to use the power rule, and on secant square x, we're going to just remember the formula for that. Again, there is no product rule in integrals. So before we do anything to this, we have to multiply it out. So this is going to be the integral of secant y tan y minus secant squared y dy. Okay? And again, referring to your formulas that I just gave you, we can just figure out what this is. Okay? Now this one is a little bit more complicated because we're going to have to use a trig identity. So recall that 1 minus sine squared x is equal to what? That's correct. It's equal to cosine squared. So we have sine over cosine squared, and if we were to break that up, it would be sine x over cosine x, which we could then write as secant x tan x. And of course, we know the integral of secant x tan x is secant x plus c. Don't forget your cookies. Okay, there's one last concept that we have to cover, and that is finding a particular solution. Up to now, we've been using C to find what we call a general solution. The particular solution finds that value, that constant that was being added at the beginning. That's what the particular solution will do. Notice in order to find the particular solution, you have to be given an initial condition, and this is our initial condition. So in other words, when x is 2, y is 4. That's our initial condition. Okay? And so the first thing we want to do is integrate. So using the skills that we've just learned, we integrate this, and we get x cubed minus x plus c. Remember your cookies. It's very important. So now we're going to use the initial condition. The initial condition said that when x was 2, y was 4. So we're going to substitute in 2 for x and 4 for y. Now we just use our Algebra 1 solving skills, and we get c is equal to -2. So my particular solution is, and all I've done is I've plugged in -2 into that solution. Okay, you can pause the video and you can try this. Notice on the second one I gave you the second derivative, and I gave you the initial condition for the first derivative, so you're going to have to integrate twice. And the answer for the first one is, and the second one. Now this one I found the derivative, and then the second derivative would be, okay? So you today should be able to find the integral of basic functions. You want to practice this in your textbook. You can use one of the textbooks on the shelves, or you can pull it up on Blackboard and use the electronic textbook. But try number 15 through 47 art, and then 55 and 59. You, of course, check your work in the back of the book, and have a great day.